Okay, students, welcome to our next math lesson in Eureka Math Module 2. This one is Lesson 12. Lesson 12 is all about angles connected with parallel lines. Angles associated with parallel lines. Angles with parallel lines. You will need pages 127 through 135 in your Module 2 books. You can rip the pages out so they might be a little bit easier to work with if you like. Please also have a page to take notes on, and you should be copying the notes on my page, put them onto your page. We've worked in the first half of Module 2, we worked a lot with rigid motions. Translations, reflections, and rotations. We worked with all three of those rigid motions. And the one thing we learned about rigid motions keep congruence. They make the size and the shape stay the same. Now that's a very important concept to know today, because today we're going to use our rigid motions to learn something, to explore something about angles with parallel lines. So the big idea to remember today, big idea that we learned, is that rigid motions keep congruency. Size and shape do not change for rigid motions. Size and shape do not change for rigid motions. Remember that today, because it's going to teach us some things about lines. It's going to teach us some things about angles with lines. That's what we're doing today. We're learning about rules with angles and lines. And we're going to prove those rules using our rigid motions. We're going to prove rules using rigid motions. And we're going to learn 4 rules today about angles and lines. Now you can see on my notes that I do not have the rules written down. That's because this is kind of an exploration lesson. We're going to explore some things. We're going to play around with some lines. We're going to play around with some angles. We're going to learn things by doing, learn things by exploring. And so I will add the 4 rules to the bottom of my notes after we learn them. So we're going to go back. So make sure your notes are in a place where you can reach, because we're going to add to them during the whole lesson. And we're going to learn 4 rules connected with 4 vocabulary terms. So it's kind of an exploration lesson and a vocabulary lesson, where you're going to learn about 4 different types of angles. Actually, 4 different pairs of angles, I should say. So let's hopefully have those notes written down. They're kind of short right now, but we will add to them later. Let's start the exploration. Let's start exploring lines and angles. On page 127, you'll see we have lines that make angles. So it says in the directions, in the figure below, L1 is not parallel to L2. So make sure you find L1. There's L1. And you find L2 so you know what we're talking about. And the instructions say that they are not parallel. And you see they're not parallel because they will hit each other when they keep going. Remember, parallel lines never cross, never intersect. These lines will intersect somewhere off the page. So they are not parallel. And M is a transversal. Here's M, the line we call a transversal. Transversal just means it goes across the other lines. So the transversal is the line that goes across the other lines. So we have 2 lines and the transversal that cuts across them. So that's a word you might need to know, transversal. Maybe you learned it in 6th or 7th grade, but you definitely need to know it now. What we're supposed to do with these lines and the transversal? Well, we're supposed to use a protractor to measure them. Now, I have my protractor here. To measure an angle, you take your protractor and you take the center of the protractor, this part going down right here, you line the bottom of the protractor up with the line, with one of the lines, and you put the protractor right at the place where the lines intersect. And then to know what it is, to know what the angle is, you have to see where it crosses. So it looks like I'm going to need to make the transversal a little bit longer so that I can measure it on the protractor. If you look, that's where the line is. Let's look and see what this angle right here. Well, let's start with angle 1. Angle 1 is right here. So I'm going to start with a 0 on this side and count up. Here's 90, 90, 100, 110, and it looks like it crosses at 117. 117. So angle 1 is 117 degrees. Angle 2 is on this side, so I start with 0 over here, and I go 10, 20, 30, 40, 50, and it looks like it's 63. So angle 2 is 63 degrees. Now I'm going to do the same thing for all the angles. I can just turn my protractor upside down, put it right here, and I'm ready to measure angle 3 right here. So because I'm measuring angle 3, I start over here at 0, and I go all the way up, and all the way 90, 100, 110, and it is, angle 3 is 117 degrees. Well, look at that. You might already see the pattern. You might already see our first rule. Well, let's check angle 4. Angle 4, I'm going to put it right there. I'm going to start with 0 on this side. Count up 10, 20, 30, 40, 50, 60, 63 again. That is quite a coincidence. 117, 117, 63, 63. I'll give you a hint. It's not really a coincidence. It's actually showing you one of the first rules we learned. But let's see what happens when we do measure angles 5, 6, 7, and 8. Angle 5. Let's do angle 5 first on this side. So I'm going to measure right here. So I set up my protractor exactly where it needs to go. And I start counting over here because this is where angle 5 is. Let me move my hands out of the way. Sorry about that. Start over here because this is where angle 5. I count up and I get all the way up here, and it is 100, 101, 102, 103, 104. Angle 5 is 104 degrees. Let's check angle 6. We're going to start on this side now. Protractor goes where it needs to go. And I start counting up. And it goes right there, right there. Start counting up. 10, 20, 30, 40, 50, 60, 70, 76 degrees for angle 6. Do you think angle 7 is going to be, what do you think angle 7 is going to be? Make a prediction right now while I get my protractor set up. Angle 7, we start on this side. We go all the way up to 90, 100, and 104 degrees. I wonder if your prediction was correct. Now, you can predict number 8. I'm not going to measure it. I'm just going to tell you it is also 76 degrees, just like angle 6. So what does this show us? What does this show us? Well, if we look, we can see angles 1 and 3 are the same, are congruent. Angles 2 and 4, same. Angle 5 and 7 are congruent. And angles 6 and 8 are congruent. They match up. Now, why do you suppose they match up? Why do you think this is true? Well, to show you, let's look at a transparency. I put my transparency on it, and what I'm going to do is I am going to trace angle 1 as an example. And where the angles cross, I'm going to put a point. And what I'm going to do is I'm going to rotate around that point. So here I go. Let me rotate. So when I rotate around the point, if I rotate 180 degrees, I can see that I make angle 3. So let me do that one more time. I start with angle 1. I traced angle 1. I rotate, and I make angle 3. And you know from the last lessons, and you know from the notes we took just a little bit ago, rigid motions keep congruency. Size and shape do not change. So the angles match. Angle 1 matches angle 3 because it's just a rotation. It is just a rotation. And if you look, the same thing works if I add angle 2 to the tracing. Let me do trace angle 1 and angle 2, just like that. And you can see it's just made, all I do is I rotate around the point in the middle, and that's where it lines up. Angle 2 turns into angle 4. Angle 1 turns into angle 3 with a rotation. The same thing happens here with angles 5 and 6 and 7 and 8. So if I trace angle 5 and I trace angle 6 and I rotate, angle 5 turns into angle 7 and angle 6 turns into angle 8. So that is a rule we have with lines and angles. Rotations keep congruency. So if you know angle 2, you also know angle 4. And if you know angle 1, you also know 3. If you know 5, you know 7. If you know 6, you know 8. This page is teaching you something about what we call vertical angles. Vertical angles kind of point at each other. Vertical angles point at each other. You can see how angle 1 is here. Here we go. Angle 1 is pointing at angle 3. We call those vertical angles. Angle 2 is pointing at angle 4. Those are vertical angles. 5 points at 7, vertical angles. 6 points at 8, vertical angles. And there you can make them by rotations. So in your notes, what this shows us, the first rule about angles, the first thing we're learning is vertical angles are congruent. Vertical angles are congruent. That is the first lesson we learned. And so vertical angles are congruent. And remember, vertical angles, you can even draw them like this. You can even draw a little diagram right here. Vertical angles point at each other. Vertical angles point at each other. And vertical angles are congruent. They match. So that's our first rule. Take a minute to add those to your notes. Pause the video, add to your notes. Make sure you understand page 127, because we're going to move on to page 128 and we're going to learn 3 more of our rules for today. Okay, class, hopefully you finished copying down these notes from about page 127. The big term for page 127 was vertical angles. You should know about vertical angles now. Let's move along. Keep your notes still handy, but move page 127 to the side. Let's look at page 128. where our diagram gets a little bit more complicated. This time, there's a big difference between what we saw on the last page. We still have line L1. We still have line L2. We still have the M transversal that crosses both of them. But this time, the difference, and you might think it is a small difference, but it's actually kind of an important difference. This time, they are parallel. L1 and L2 are parallel. So you might think it's a small difference, but it actually is going to be very important to the rules we come up with, because these rules only work with parallel when the L1 and L2 are parallel. The transversal can cross at any angle it wants. But what's important for this is that we are talking about parallel lines. So make sure you remember that these are rules when the L1 and L2 are parallel. And then the next step is it wants us to measure the angles 1 through 8. Measure angles 1 through 8 using our protractor. Well, I showed you how to use a protractor on the last lesson. I'm not going to show it to you again. If you want, you can pause the video right now. You can practice using your protractor to measure the angles. But right now, I'm just going to tell you what the angles measure so that we can move the video along a little faster. If you're watching the video, you can go back and measure them yourselves with your protractor. Just pause the video. If you're doing the live lesson with me, then what I would encourage you to do is after the live lesson is over, get your protractor and practice your measuring skills. It's okay to practice after I tell you the answers. So it's okay to practice after I tell you the answers because you're practicing using a tool. So I'm just going to tell you the answers because it's faster for the lesson. Angle 1 is 39 degrees. And you know from page 127 that angle 1 and angle 3 are pointing at each other. So you should know angle 3 is also 39 degrees. Well, I'm going to tell you angle 2 is 141 degrees, which you should already right now, if you're paying attention, you know angle 4. Because angle 2 and angle 4 are pointing at each other. They are vertical angles, so angle 4 is also 141 degrees. Now, angle 5 down here, I'll tell you, is 39 degrees. And the super clever students already know 6, 7, and 8. 7 is the easy one because you know 5 is 39. 7 is the vertical angle, so 7 is also 39 degrees. Now this, for angle 6 and 8, is really a test to see how much were you paying attention in 6th and 7th grade. Do you know what supplementary angles are? Because if you look, angle 5 and angle 6 together make a straight line. And you might remember from 6th and 7th grade that a straight line is 180 degrees. So you know if 5 and 6 make a straight line, that means 39 degrees and 6 degrees have to make 180. Because 5 and 6 make a straight line, their angles have to make 180 degrees. Those are supplementary angles. They go together to make a straight line. So 180 minus 39 is 141 because 39 and 141 make 180. So now you know 5 is 39, 7 is a vertical angle, so that's 39, 6 is 141, and you know 8 is a vertical angle, so 8 also has to be 141 degrees. Now, you might be sitting here going, wait a second, Mr. Baylor, I see a lot of coincidences. I see a pattern in the diagram you told me. And if you don't believe me, get your protractor and you can test it. You can check the angles. You can check all of them with your protractor and see how these numbers work. But if you see this pattern, let me show you the pattern for the people who might not see it. Angle 1 is 39. Angle 3, the vertical angle, is 39. But wait, angle 5 is 39. And angle 7 is also 39. And then angle 2 is 141. 4 is 141. 6 is 141. And 8 is 141. So what is going on here? Why do we have this pattern? Why are there only 2 types of degrees in this diagram? And I'm going to tell you, it's because, like, you might go back to page 127 and say, Mr. Baylor, we did not have so much matching. Why is page 128 matching more than page 127? And I'm going to point to this word that I wrote at the top of page 128, parallel. When L1 and L2 are parallel, we see a lot more coincidences. We see a lot more patterns in our numbers. So because the 2 lines are parallel, there are some patterns here. So let's answer some other questions for us after we have all these labeled, and then we'll talk about some of the vocabulary terms. Part A. What do you notice about the measures of angle 1 and angle 5? Well, angle 1 is 39 degrees. Angle 5 is 39 degrees. So what do we notice? We say angle 1, and I'm going to use a symbol we learned in the last lesson. Angle 1 is congruent with angle 5. Why do you think this is? Use your transparency if needed. Well, I'm going to show you a trick with the transparency right now. Well, let me show you the trick after we answer the questions for B and C. B, what did you notice about angles 3 and 7? Well, 3 is 39 and 7 is 39. So angle 3 is congruent with angle 7. C, what did you notice about angles 4 and 6? Well, angle 4 is 141. Angle 6 is 141. So angle 4 is congruent to angle 6. We have a lot of congruencies. I'm not going to call them coincidences in this. We have a lot of congruencies. So let me show you why. Let me show you why with the transparency. Just like on page 127, we use the transparency to rotate. Well, watch what happens. My transparency is on there. Let me trace angle 1. And let me show you for part A why angle 1 is congruent with angle 5. Some of you, I'm going to use a rigid motion. Watch what happens. If I just slide down, angle 1 turns into angle 5 after a slide. You can see the slide down. You can even draw the vector if you want. What vector does it follow? It follows the vector along the transversal. That's my vector. So I follow my vector and I make angle 5. So angle 1 is congruent to angle 5 because a translation maps angle 1 onto angle 5. Why are they congruent? because a translation maps them. And then let's look right here. The same thing is true for part B, angles 3 and 7. Let me erase my transparency. Let me trace angle 3 on my transparency. And you'll see that if I just take angle 3 and slide it down, it makes angle 7. So why is 3 congruent with 7? Because a translation maps angle 3 onto angle 7. If you remember in your notes, I told you that we're going to use rigid motions, and that, remember, rigid motions keep congruency. The size and shape do not change. So when angle 3 slides down to angle 7, the size stays the same. The degrees stays the same after the slide. Hopefully you can see that. What about angles 4 and 6 for part C? We said angles 4 and 6 are congruent. Will a translation work on them? Let's try it out. Let me get my transparency ready to go. Let me trace angle 4. And I need to prove that it makes angle 6, because remember we said in part C that angle 4 and 6 are congruent. But a translation does not move it to 6. So what am I going to do? How do I prove that angle 4 and angle 6 are congruent? Well, I'm not going to use a translation, because a translation won't do it. But what will do it is a rotation, another rigid motion. I need to use a different rigid motion. Let me show you, because this is actually pretty cool when you see it all line up. So what we need to do is let's put a point halfway on the transversal. Let's put a point halfway on the transversal. About right there. That's my point. That is right in the middle between both parallel lines. That is right in the middle of the parallel lines. Let me show you this, because I like this. I'm going to trace the angles up here. And I'm going to actually label them. Angle 1, angle 2, angle 3, and angle 4. And I'm going to keep my point right there on the center point. Now I'm going to rotate around the center point. Watch what happens when I keep the center point exactly where it is. I'm going to spin around it. So I started here. Now I'm going to spin around the center point. Look what happened. Angle 1 turned into angle 7, and it matches perfectly. They're congruent. Angle 2 turned into angle 8, and they are congruent at 141. So 1 and 7 line up right here. 2 and 8 line up. There's my 2, and it lines up with 8. 3 and 5 line up right there. And 4 and 6 line up. Just like we said they were congruent in part C. Now we proved they are congruent with a rotation around. So this is why 4 and 6 are congruent, because you make a middle point and you spin around. You rotate around, and that is how 4 turns into 6, 3 turns into 5, 2 turns into 8, 1 turns into 7. I know it's a little bit tricky, so watch it again, try it yourself with your transparency, and see how the angle rules are made with a rotation. See how the angle rules are made by a rotation. So for part C, why is angle 4 congruent with angle 6? Why do we think that? Because a rotation maps angle 4 onto angle 6. For A and B, we used a translation. For angles 4 and 6, for part C, we used a rotation. Very tricky thing, but very fun to see how it works just like that. So now you saw how it worked with translations and rotations. You learned some things about how the angles match up. Let's talk about the rules we have for this. Let's talk about the rules, because this is the vocabulary time. This is vocabulary time right here. So for vocabulary time, I need to tell you the names of some things. So we're going to learn about 3 different vocabulary terms right here. We're going to learn about corresponding angles. We're going to learn about alternate interior angles. And we're going to learn about alternate exterior angles. And this is a vocabulary, these are vocabulary words that you're just going to need to practice, you're going to need to learn, but today's lesson will help you with this. So, corresponding angles. Corresponding angles are made by translations. Corresponding angles are made by the translations. So corresponding angles, because corresponding's in blue, this is a corresponding angle with 5. Remember in part A, we made 1 and 5 match with a translation, so that's a corresponding angle. Just like 2 and 6 are corresponding angles, we make them with translations. So corresponding angles are with the translations. That's what we did with 1 and 5. That's what we did with 3 and 7. We made them with translations. Alternate interior angles and alternate exterior angles, these are both made with rotations. If they match with rotations, that's alternate interior and alternate exterior. The only difference is alternate interior are inside the parallel lines. So alternate interior are like 4 and 6. 4 and 6 are alternate interior angles, because they are made by a rotation and they're on the inside of the lines. Alternate means flipping over the transversal. So corresponding angles are made by translations, like 1 and 5 or 3 and 7. Alternate interior are made by rotations, like 4 and 6. Alternate exterior are made by rotations, like 2 and 8. I know it gets a little bit confusing because some angles have more than one. So like number 1 is corresponding with angle 5, but it is alternate exterior with angle 7. It can be confusing. I am going to give you a diagram with these rules listed on them in a diagram that will help you. But let's add these to your notes so that you have them in your notes. So let's get our note page back. And we're going to start. We did vertical angles that point at each other. For number 2, let's talk about corresponding angles. Corresponding angles are congruent. They are the same. They are made by translating. I'm spelling things wrong. Made by translating. And let's do a little bit of a diagram right here. Corresponding angles. Like there and there are corresponding angles. Or here and here are corresponding angles. This and this are corresponding angles because they're made by translations. And that are corresponding angles. Corresponding angles are made by translations. The third rule, we have alternate interior angles are congruent. And these are made by rotation. So let me show you a diagram of alternate interior angles. Let's do parallel lines. Let's do a transversal. Alternate interior, these are opposite sides of the inside, so those are equal. Those are congruent. And these are also alternate interior. So red equals red, blue equals blue, because they are alternate interior angles. Red equals red, blue equals blue, because they are alternate interior angles. The fourth vocabulary term we're going to need we say that alternate exterior angles are congruent. And these are also made by rotation. Let me diagram this for you. We have parallel lines. We have a transversal that crosses both the parallel lines. And alternate exterior means they're on the opposite side of the transversal on the outside. So green equals green. And blue equals blue because they're alternate exterior angles. So this can be confusing at the first. This is why this takes practice. This is why you need to study your notes. This is why you need to review. So in the video, go back and pause and look at these things again. I'm going to go through all 4 rules from today one more time. Starting with rule 1, vertical angles are congruent. They point at each other. They are congruent. You make it by rotation. Number 2, Corresponding angles that you make by translating are congruent. So that's why red slides down to make red, orange slides down to make orange, blue slides down to make blue, green slides down to make green. If you can slide it with the translation, it's a corresponding angle and they are congruent. The third vocabulary one, alternate interior angles are congruent. So if you can make it by rotating and the inside, the interior of the parallel lines, they are congruent. So red equals red because it rotates around. Blue equals blue because it rotates around. And they're called interior angles because they're inside the parallel lines. Like the alternate interior angles, we have the alternate exterior angles. These are also congruent. You also make them by rotating, except they're on the outside of the parallel lines. So green rotates around to make green, and blue rotates around to make blue. They're made by rotations. They're congruent. They're on the outside, the exterior of the lines. They're alternate exterior angles. Go back and rewatch the videos. Make sure you practice with these. Study your notes. Study the vocabulary. These are important terms to remember. But this is recorded. You can watch it as many times as you need. And remember, you can always reach out to me with questions if you have any questions. Take a minute to look at your notes, add these to your notes, go back in the video, and then we'll talk. And then when you come back, we'll talk about the problem set and the exit ticket for today. Okay, so hopefully you took a little bit of some time to catch up on your notes, to add things to your notes, and to just review them. We learned about, we explored some lines a little bit. We used rigid motions to prove some things. The first thing we proved is that vertical angles are congruent because we can spin them around. So when they point at each other, they are equal. We also learned corresponding angles are congruent. When we slide the angle down, it matches, it makes congruency. So here's our diagram with the different colors are all equal to each other because they are corresponding angles. We also learned about alternate interior angles. They are made by rotating. So the red rotates around to be red, blue rotates around to be blue. And they are all equal. And they are interior angles because they're inside the parallel lines. We also learned about exterior angles. They spin around and rotate also, but they're outside the line. So green spins to make green, blue spins to make blue. Page 127 taught us about the vertical angles. Page 128 taught us the other three rules. Page 129 has a lesson summary. So this is your little diagram here where it tells you, it summarizes everything. So the first little paragraph tells you about corresponding angles. So it tells you, it reminds you here and gives you examples of corresponding angles. The second paragraph tells you about alternate interior angles. So if you need a little bit of review about alternate interior angles, look at the second paragraph. And alternate exterior angles is the third paragraph. So the lesson summary will probably help you on this. As a little reminder, this is the diagram you can use to see what's equal. So if we say corresponding angles, we're talking about anything that slides to make them. Alternate interior, alternate exterior, anything that spins. And remember, this was all about rules about what angles are congruent, what angles are the same. So here's the exit ticket, page 131. I'd like you to set that aside for right now because it's the last thing we're going to talk about. Page 133 is your homework helper. And it's also on page 134 where they ask you questions where it says, number one, like identify all pairs of corresponding angles. So it says find the corresponding angles. And then it tells you the answers for corresponding angles. So you can look and see they give you a real example of corresponding angles. So use your homework helper when you're doing the problem set, when you're doing the exit ticket. Number 2, identify all pairs of alternate interior angles. And then it gives you the answers. So the homework helper has real questions where they give you the answers and they show you the thinking. Page 134 and also gives you answers and explains the thinking. And these questions are super, super similar to the problem set. Speaking of the problem set, here it is on page 135, where it says, it gives you a diagram and says, answer the questions. So like number 1 says, find the corresponding angles. That sounds a lot like the homework helper. Number 2 says, find the alternate interior angles. And then it's asking you questions about everything here, where it says, are they equal? How do you know? Tell me why they're equal. If the angle 4 is 73 degrees, what is angle 8? If angle 3 is 107 degrees, what is angle 6? So tell me the new angles, and then don't forget to also tell me how you know these things. How do you know? How do you know? Give me explanations, please. Use the rules in your notes to tell me how you know these things. So you might say, well, angle 1 is equal to angle 5. I know this because they are corresponding angles. Angle 4 is equal to angle 5 because these are alternate interior angles. So you can do these things using the rules that we learned about in the lesson today. And don't forget, my answer sheet to the problem set will be posted online, so you can always check your answers for the problem set online. Then finally, after you check your answers for the problem set, you are ready for the exit ticket. The exit ticket has 2 questions. It tells you L1 and L2 are parallel, and they are crossed by a transversal. And number 1 says, what do you know about angles 2 and 6? What do you know about angles 2 and 6? Tell me everything you know about angles 2 and 6. What vocabulary word describes them? And what does that tell you about their measures? And for number 2, what do you know about angle 1 and angle 3? Tell me the vocabulary word and what you know about their measurements. So for this, I want the vocabulary word and what do you know about the measurements. You don't need to tell me the exact degrees, but what do you know about the measurements just by using the vocabulary word. So that's your work for today. Remember, always reach out to me for help if you have any questions. If you'd like me to work on the problem set with you, reach out to me, ask for help, and I will be here to help you. If you understand it, that's amazing. Have some fun with it. Work hard, and I will see you for the next lesson.